To produce t-shirts is $5 to set up and $1.50 per shirt. Graph the relationship and write the equation. In order to create the graph, I will need to set up the scale for the X and Y axis. The X-axis, or the independent variable, will be counted by single ones because we'll be counting shirts. The Y-axis is the dependent variable, and so that's cost, and cost increases by $1.50 and starts at $5. So I know that my scale for my cost needs to count up by $1.50, and I'm going to start counting after my squiggle mark at 5. So I can label the X-axis, or the independent variable, as number of t-shirts, and the Y-axis, or the dependent variable, as cost, because the cost is controlled by the number of shirts. So as we said earlier, we're going to count shirts by ones, so the corner will be labeled 0, and then I'll count by ones. I have enough space that I'll actually count 2 grid lines is 1 t-shirt, so I'll label those. We also said that the cost is starting at $5 because that's the setup fee, and it's going to go up by $1.50. So this time when I increase on my grid lines, I'm going to go up by $1.50, but I don't need to start counting until 5 because there's no cost before $5. So I've labeled the 5, but I'm going to start skip counting, so I need a little squiggle mark. And now I'm going to count every other line, so that's 5, is going to be $1.50 more. So 5 plus $1.50 is $6.50. And then $6.50 plus $1.50 is $8, and $8 plus $1.50 is $9.50, and $9.50 plus $1.50 is $11, and finally $1.50 more is $12.50. So now I can quickly create my graph because my y-intercept, or the starting fee, is $5. So the first point is at $5. And then I'm going to go over 1 t-shirt, and as I go over 1 t-shirt, the price increases by $1.50. So my next point will be at the $6.50 mark. There's another point. Then I will continue to use my rate of change and go over 1 t-shirt and up $1.50 to 8. And then again over 1 and up $1.50 to $9.50. I can continue in this manner to fill out the rest of the points on the graph by going over 1 as a run and up $1.50 as a rise. Now, since I have a linear relationship, because that follows a straight line and all the first differences are $1.50, and I have a partial variation because it doesn't start at 0, it starts at 0.5, then I know I need to use the equation y equals mx plus b. M is the rate of change, and I know the rate of change because I used it to make my graph. Up $1.50 over 1, so the rate of change is 1.50 or $1.50. I also know the y-intercept, or the initial value, because that's $5 and that's what I have to pay for setup. So the b value will be 5, and it's positive 5 because I'm starting with positive money. Recalling that the rate of change can be short formed with m, and seeing that the x-axis is about number of t-shirts, then I can write the rate of change, or $1.50 times the number of t-shirts, add $5, my initial rate, will give me the cost for any amount of t-shirts. So I'm going to write the equation that y is equal to $1.50 x plus $5. So the only time that we can't use the b value as a starting place and the rate of change in order to construct the scale on the y-axis is when you have a negative slope, because then your starting value, which might be up high, needs to have a decreasing line. So we can still use the rate of change to talk about how I'm going to count, but I need to have a line going down. So if my squiggle mark was appearing over here, then I wouldn't be able to see my line. So the rate of change, or m, is equal to -2, also known as -2 over 1. So I need to go down 2 for every unit that I go over 1. And the b value is 12, so that means I need to start or have a y-intercept of 12. So I'm going to start with that point. And now I need to use my rate of change and go down 2 and over 1. Now on this grid line, my y-axis is 1 value for every tick mark, and on my x-axis it goes over 1 value for every 2 grid lines. So I am actually going to use, to create the next point, I go down 2 and then I slide over to the value 1. And then again I will decrease by 2 and then slide over to the value 1. There. And I can continue in this fashion to create my graph. Oops, I've missed a little bit. The last thing to do then is to create the line, because this is just x and y and I don't have any reasons why I wouldn't be able to have middle values. Like in the previous example, I couldn't have middle values of t-shirts. I could only have 2 or 3 t-shirts, not 2.5. In this case, I can just create a straight line. So to summarize, to graph most lines very quickly, I can use the rate of change as long as I consider it as a fraction, the top value being the way I will count my y values, and the bottom value of my slope or rate of change to be how I count along the x-axis. This will always work. And then if I have an increasing graph, then I can start my point at start my graph at the y-intercept and then count up from there. That didn't work in this example because I have a negative slope or negative rate of change. So as I start at my y-intercept, I have to continue to go down, and so then I cannot use the squiggle line. This value is not allowed when I have a negative rate of change.